Hello. In this video I'll show you how you can teach your robot in the XR for industry environment in combination with our tooling, so that you can use the coordinates as a starting point for your Keil program. As you can see, here you see several robots. For now this one is not working, but that will be solved in the future. The rest does its work, and we will start this one as an example. Now the question is, which one is this one? We have to determine which name this thing has, and the easiest way is to use .model here. It starts XR to configure where we can use to change our model, and that's something that you are also going to do later. Connection here, and then connect, and then if I select this one, you see that that one is the one we need, and if you select another robot, you see that another one is selected. And the grippers here are the grippers that are placed on top of each robot. Now, okay, so we need a UR5E male TCP1. Okay. The view here can switch, and we have a robot movement tab here, and if we select that, we can select the robot we want, and we can select the proper one. And as you can see, it's in initial state, all zeros, and we want to put the gripper at the point where the product will stop. First of course we need a stop, and keep in mind that it's impossible to use the Keil program to control it and the jogger that we are going to use, so because they would influence each other, and that's something that we don't want. So first I'll run our robot test until the point that it stops the conveyor at sensor 1, as you can see here. So it stopped at the proper position, and now we're going to put that point to there, and we start the jogger. There, start jogger, connect, and then select the proper one. Here you see all the items, and depending on the type of robot, you need the TCP target, which is the endpoint there, or for the Epson and the UR16, the UR16 is this, the Epson is that one, you need the TCP output here to control it. And if it doesn't work, just try another one. So let's start with the UR5 TCP target and try to do some movements, and we are really moving that point in a coordinate system. The X direction is in that direction, the Z direction is in this direction, and the Y direction is up down. And of course it has to go at least to the back, so that's the Z direction, minus Z, sorry, I have to take the... Sometimes it's a little bit difficult to start, but when it's going, then it's going. The Z direction, as you can see, is not right here, and we also have to turn there something. So let's turn 90 degrees. Let's try something with the X-axis. It's not what I wanted. Also the Y-axis, more like that, and maybe wrong one, then it's probably the other way around, more like that, so it's more in the proper direction. The Z still has to be a little bit less, and then we have to go down in the Y direction, and as you can see it makes strange movements. Oh, that's too much. Let's try to get it a bit better. It has to go forward towards the cursor here. That means that the X position has to be added. No, not too bad. Not correct. As you can see, now in this Z is too much. So let's go further in the Z direction with a little bit too much. So let's make smaller steps. Z minus, well, that's better. And still, it's not that bad. I can go a little bit up. So let's make Y. Well, I think it's okay for now. It will grab a little bit of in front of the disk here, so you have a little bit of margin. Well, this is the values I want to use in my program, and you can take them from here. And the other way is to say save, do it twice, and then do a copy CSV, which gives you too much values. I can tell you, copy CSV, doesn't matter, and then paste it here, and you see a lot of duplicates because it wants to make some steps. A little bit different. Let's take the last positions, and we are going to use these in our program and just double check it and test it first in our environment. Close the jogger, and then it will move back to the initial position. Doesn't matter. We are going to use this, but remember that the comma has to be a decimal point here in our program. Well, this is almost 0, so let's use 0 for X. Let's use minus 0.785 and minus 0.735, 90 degrees, minus 180 and 90. And there are several solutions that go to the same end position, but so don't forget, the comma here has to be a decimal point here, and also of course in your Keil program later. Let's see what it does. Update. The strange things, I know, and you can correct this by adding extra positions in between. We close the gripper, and then we go a little bit up to see if it works. Well, that's not enough. Minus 7. No, it's moving, and yes, you can see it picks up the block, so that's okay. And if you want to correct this, then you have to make a path and take a few steps, but we'll not handle that. So 785, that's okay. So update again. Well, it's at the proper position, and we are going to use these now in our Keil program. So here's the Keil program, and the name is the name of the robot here, of our robot, and we need to set some values, so that are being used here to send a command. And the command is like this: 2 strings, the robot name, a move to what it has to do, and then all kind of values, x, y, z, and the rotations. We put them in a command using an sprintf, and then we send the command, and then we are also waiting for the robot. Robot 1 is busy, and as long as it's busy, we read the value, we will wait. Okay, here are the data being used, so let's stop and just take them. We say that x was 0, y was 7, 8 minus 785 minus 735. The rotation was 90, minus 180 and 90. What this says over here. Okay, it's probably because something is still wrong, but doesn't matter. First, oh, there it is. Oh, we didn't reset, so let's first put it to another position. 0 update, so that we at least see that it's doing something. So code. So okay, let's start the program. It stopped. What I do then is that I give the command that it has to move to the positions we entered, and after that it waits to be ready, and when it's ready it grips, and after it grips I move it a little bit up. As you can see, I gets a little bit higher, Y, and then we wait until it's ready, and then we will stop gripping again. So let's see what it does. It should take it up and stop. There it is. Makes a strange movement. Okay, it seems I'm a little bit too fast or something. So let's do its work again. There it is, and now it picks it up and it drops it again. Picks it up, drops it again. So timing might be an issue somewhere, but at least the idea is clear, I think. Use the jogger to jog it to a certain position. You can then use the values here to update it and position it better. Check with the gripper if it's working, and then use these values in your program. And if it makes strange movements, as you see here through the belt, then you have to enter some in-between positions so that it moves as you want to. Okay, thank you, that's it, and until next time.